Hello everybody, this is the notes, the second part of the notes for section 2.2. It's something that can be used throughout any kind of function, but transformation, so basically just moving the equations around. So, to talk about these transformations, gotta talk about two things. Gotta have a parent function, like what is this main function that all these changes are based off of? And that's what we have up here, in this upper right corner. That's the starting function. That's our f of x. Let's just say, so we can have an example carry through all the way, that f of x equals, oh, this can't be an x cubed function. That doesn't work with the way the graph looks. Something like an x to the fourth. You know, the x to the fourth graph is not going to give you that, but just as a simple, basic, here's our parent function. This is what we're starting with, okay? So, the different types of transformations. We have shifts or a translation. We got shifts up, down, left, or right. So to do a shift, what you're looking at in the equation is you're either adding or subtracting. Now, where you add or subtract tells you the direction, and how much you're adding or subtracting tells you, how much you're moving it left, right, up, or down. So this first one right here, we are taking our parent function, f of x, which for our example is x to the fourth. And then we are adding a number to this, so like plus 5. So what that means is we're going to take our parent function. It started right here, and I'm going to use this point where it started at the origin. That's going to be our basis for all of these shifts. So if that's our x to the fourth graph, when we add 5 after the x to the fourth, all it does is just shift that graph up. In this case, it would be 5 units. Okay. The next one. Here is our, again, the parent function is the f of x. Now you're subtracting a number, so something like x to the fourth minus 5. Again, let's start with our parent function with that point at the origin. If you subtract a number after the parent function, all it is shift down. Okay, the next one is this middle one here, f of x minus h. All right, so now we're changing where we are adding or subtracting. Before it was after the parent function, plus 5, x to the fourth plus 5, x to the fourth minus 5. Now we're subtracting directly from the x value. So that's going to change the look of the equation now. So for an example of f of x minus h, if f of x is this x to the fourth idea, what we have is x minus 5 to the fourth power. So we are subtracting directly from the x value. When you do that, that is a shift to the right. And so again, what we're going to do, we're going to take our parent function. It started right here with this point at the origin. When we subtract 5 directly from the x value, all we're doing is shifting that graph 5 units in the direction of to the right. Same idea with this next one here, f of x plus h. You are adding directly to the x value, not changing anything else. So we take our parent function, where this point started at the origin, and now when you add directly to the x value, now you're shifting it to the left. Okay, that's the look of our shifts and what you're looking for in the equation. But you're always starting with a parent function. What is that basic function? And then, are you adding, subtracting? Are you adding or subtracting after the parent function? Are you adding or subtracting directly to the x value? That tells you left, right, up, down. Next type of transformation is reflections. All right, so again, we're starting with a parent function, whatever it is. Let's go with the x to the fourth again here. When you have your parent function, f of x, whatever it is, and you put a negative out in front of that, you got to think of f of x as your y value. So now you just put a negative out in front of your y value. That's going to change from positive y values, and it's going to flip it over into the negative y value area. So if this is our parent function, when we put that negative out in front, looking at this equation right there, all you're doing is reflecting over the x-axis, all right? So you can see how this point didn't move because it's on the x-axis. This point didn't move, it's on the x-axis. Same thing here. But you take this positive graph from here to here and reflect it over the x-axis, now you've got this part down here. Okay, same thing all the way around. So you're putting a negative out in front of the parent function. That's changing the sign of the y values, which is a reflection over the x-axis. The next equation to be looking at is right here. Now you're putting that negative in with the x value. So, like this would be a negative x to the fourth. Now, this is not a great example for this function because negative x to the fourth is x to the fourth, but you know, it works with all these other functions. It just happens to be kind of a weird one with this x to the fourth equation. But you still get the idea. We are starting with this black graph with that point still at the origin. When we throw that negative into the x value, what we are doing is changing the sign of all of the x coordinates. So what were positive x coordinates are now going to reflect over to be negative x coordinates. That's just flipping the graph over that y-axis, okay? And that's your transformations. Those are the main ones. I mean, there are some rotations, but that takes on a whole different level of things that we don't really need to talk about. So our shifts, adding and subtracting, the reflections. There are some scale factor changes by multiplying, and we kind of talked about that with the parabolas, that number a, that was the ax squared, that changes the scale, all right? That's it. Have a great night, everybody.